Gender differences in math is a huge topic, has been in the media repeatedly. What's really interesting is when you look at the research literature, when you look at large-scale meta-analyses, so there's a researcher, Janet Hyde in the United States, she's published many papers, including papers in Science, where she's collated data from tens of thousands of students. And what she does is she calculates the effect size of the gender differences. So how big is this gender effect really? And turns out that the effect sizes are tiny. So you don't see very large gender differences in the math outcomes. Now that doesn't mean that there aren't gender differences in the approach to math, in the approach to learning math. But in the outcome measures, standardized test results from school districts throughout the United States, the effect sizes are tiny. And Janet Hyde actually advocates for what she refers to as a gender similarities hypothesis. So she doesn't just restrict it to math, but she also looks at science, and she looks at reading, where in reading, in fact, the reverse is true. So girls are much better than boys, and the effect sizes are large. So when you look at the effect sizes in literacy, in reading skills, for gender differences, they're very large, but they're never talked about. At least I don't see big headlines about gender differences in reading. Gender differences in math are tiny, the effect sizes comparatively, yet they receive way more attention. What I would like to say about gender differences, I think, is much more important than understanding whether they're there or not empirically, is the effect that our cultural stereotype about gender differences is having on female students. And there's a phenomenon referred to as stereotype threat. And in gender differences, it goes something like that. If you're a female student and you've heard repeatedly that boys are better than girls at math, you embody that stereotype, and that stereotype affects your performance. And you can show that in controlled settings where you give students, you induce the stereotype threat by telling them about some study that suggests that boys are better than girls, and before they actually performed equally well, but after the stereotype threat induction, the girls start to look worse than the boys. Now, the good news is that that's reversible. If female students are giving the accurate facts about gender differences, then you can reverse those performance differences as well, showing that it's really the stereotype threat that leads to the performance decrement. It's nothing intrinsic about that. But I think this is another example of how important accurate portrayal of scientific knowledge in the public sphere is, and especially in education. There's been so much research with infants, human infants, on things such as their object knowledge, how much they know about number, their naive physics, their language understanding. If you look at those studies and you look for gender effects, they're just not there. So, if there was anything to this notion that there are innate differences in abilities in certain domains, it doesn't seem to be very good evidence for that.